Today we would like to introduce the latest IP core from NVMe-IP Series by Design Gateway, rmNVMe-IP. For this rmNVMe-IP video, we will divide into 3 parts. This video is the first part for introduction. The second part will be example applications and the third part is the IP core demo and performance result. Let's start it. rmNVMe-IP core for PCIe Gen 4 is the complete, versatile solution that provides many features. It is designed to achieve optimum performance for both random access and multiple users applications with NVMe Gen 4 SSD. Many NVMe-IP products are proposed by Design Gateway to match with various system requirements. First is the NVMe-IP, which is the standard IP that has one user interface and achieve the highest write and read performance by using sequential access. Second is the rmNVMe-IP, which has one user interface but supporting for random access. Third is the munVMe-IP, which has many user interfaces for sequential write and read with high performance. While the latest IP is our rmNVMe-IP, which can support both multiple users and random access. The general system has only one logic block to access the NVMe SSD by write command or read command at a time. As a solution, rmNVMe-IP for Gen 4 supports multiple write commands or multiple read commands, with a simple user interface and low resource utilization. However, some systems require the ability to write and read the SSD simultaneously, for which our rmNVMe-IP is the solution. It has separate user interfaces for write and read commands, allowing for concurrent data access. However, our rmNVMe-IP requires more resources for both logic and memory, compared to rmNVMe-IP. Both rmNVMe-IP and our rmNVMe-IP for Gen 4 have a fixed data size per command of 4 kilobytes and offer configurable command queue depth to balance performance and resource utilization. For systems that require multiple user access to the same SSD at the same time, 2 IP solutions are proposed, munVMe-IP and our rmNVMe-IP. Both IPs have multiple user interfaces and a configurable buffer size to optimize resource usage and performance. munVMe-IP is best suited for systems that require high-speed writing and reading of data with an NVMe SSD. Using large transfer sizes for each write-read command to store data in contiguous areas of the SSD will always result in the best write-read performance for the SSD. On the other hand, our rmNVMe-IP is best suited for systems that require random access to write and read different types of data stored in different locations on the SSD. The transfer size for each write-read command is fixed at 4 kilobytes. As per the rmNVMe-IP specification, the command queue depth can be adjusted by the user to meet desired write-read performance levels. The relationship between command queue depth and write-read performance is demonstrated through a graph, utilizing a 1 TB Samsung 980 Pro SSD and 4 KB command. The command queue depth refers to the maximum number of commands that can be simultaneously sent to an NVMe SSD, and can be set anywhere between 1 to 128. The graph showcases that with the write command, the write speed increases when the queue depth is increased from 1 to 32, after which the speed remains constant. Meanwhile, the read command consistently shows an increase in read speed as the queue depth increases from 1 to 128. To optimize write performance, a command queue depth of 32 is ideal as it provides maximum performance with minimal resource usage. The rmNVMe-IP contains the write and read buffers to temporarily store data during write and read commands, respectively. The rmNVMe-IP enables individual configuration of the write and read command queue depths, offering 4 options as displayed in the table. Increasing the command queue depth increases the buffer size and memory usage. The correlation between command queue depth and write-read performance varies for each NVMe SSD. Hence, the optimal command queue depth value varies based on the specific characteristics and system requirements of each NVMe SSD. When operating 4 KB random write and read tests using our rmNVMe-IP, the results of 3 SSDs are displayed in a graph. The graph shows that 3 SSDs exhibit a constant rate for the write command while adjusting the write command queue depth to values of 32, 64, 128, and 256. 2 SSDs display an increased read speed when the read command queue depth is set to a larger value. However, the Intel P5800X exhibits a constant rate with the highest performance during random access tests of 4 KB size for both write and read operations. Hope this Part 1 video can help you understand the concept and features of our rmNVMe-IP core. Part 2 for application and Part 3 for demo and performance will coming soon. For more technical detail, please visit our website designgateway.com or just click the link in the description below. Thank you for watching and see you in next video.